Hi all, and welcome to the second part of the recursion chapter, which is part of our algorithms and data structures course. In this video, we will go over an algorithm problem to better understand how to use recursion, swap nodes in pairs. This is a medium difficulty problem on LeetCode, and I will show you how applying the 7 steps from the previous course will make this problem easy to solve. I will add a GitHub URL where I post all the problems I'm working on and document every data structure and algorithm as well, so you can follow along my progress. Before we continue, please take just a second to like the video, as it helps with the YouTube algorithm so that more people can benefit from this course. Also, please subscribe so that you will receive notifications when a new section of our course will be released. Now let's read the text of the problem and understand our requirements. Given a linked list, and just a parenthesis here, don't be scared of the term linked list. In the next course, we will learn about linked lists, and if you want to know more about them, they are just like normal lists, only that each element of the list is a node object containing the value of the node and a pointer to the next node. We will go deeper into linked lists, like I said, in the next video. If you want to know more about them, you can read on your own as well, but this video is more to show you how, if we apply those steps, we can easily go through any problem of any complexity. So once again, given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list's nodes. What that means is that only nodes themselves may be changed, meaning that we don't swap the value of node 1 with node 2, we just swap the whole node, which means that we also have to change these references. Let's say we want to swap node 1 and 2. We change the reference of node 1 to node 3 and of node 2 to node 1, and then they will swap. This is what swapping two nodes in a linked list means. Now that we understood what the problem requires of us, we will move into the conceptual overview, where we will draw the algorithm and we will go again through the 7 steps. And after that, we will come back and code the solution in both Java and Python. Let's understand this problem conceptually by implementing once again the 7 steps so they can become more clear in the future and how to work with them. So let's say that we take the example that LeetCode gives, and that is 1, 2, 3, and 4. So this is step number 1. We pick up a few examples and understand the algorithm. So in this case, let's pick up the example where we have only 3 nodes, because that is the easiest, right? And how would we swap node 1 and 2? Well, first thing what we will do, we would change the reference of 1 to 3. So now the 1 points to 3. We'll change the reference of 2 to 1, and basically 2 becomes head. So in this case, the response to our problem is 2, 1, and 3. So we understand how to do, right? For the simplest case, now if we have 4 nodes, we then have to move along to 3. So our pointer current becomes 3. We switch 3 and 4, so 3 would point to null, then 4 would point to 3, thus the references are changed. So we understand a bit how this functions, right? So we swap two nodes, then we move on and we move on until we don't have anything else, right? Second step is select the base case. For this, what we need to do is to see where the list is null, or the list has only one element, or stuff like this, right? And we see what? We see that if we have no nodes or only one node, there's no swapping to be done. So in that case, that is our base case. So we say that if head is null, right, this means we have no nodes, or head.next is null, meaning we have only one node, then we return head. Perfect, we have our base case. Now we move forward and to step 3, which is decide which arguments to pass to the recursive function. Here it's quite easy, because if I get our recursive function, what is the only argument that continuously changes? Is head, right? Because first we start at 1, we switch 1 and 2, head has to move to 3, so that we switch 3 and 4, and so on and so forth. Thus, head is the parameter of our method. So once again, like we showed in the previous course, only after 3 steps, we already have a recursive function which takes in the the head of the list, which has a base case, which is if head is null or head.next is null, then we return head. So we have quite a lot already, right? Now let's move into step number 4 and understand how that works. Step number 4 says figure out how to break the argument into two pieces, simple case and the rest. We can break the argument into simple case, which is not the base case, and that is 1 and 2 and 3, and the rest, which is 3 and 4. And if we had more nodes, would be all the others, right? Because for simple case, we don't need to do any recursion. We solve it iteratively, and we solve it just like we saw in the step number 1, where we just swap nodes 1 and 2, right? So we know how to swap nodes 1 and 2. Now we go to step number 5. Solve the problem for the simple case non-recursively, right? So that's easy. We saw already how to do that. We need node 1, which will be the head. We need node 2, which is the head.next, and we also need node 3, which is node2.next. And in order to solve the problem, we need to say node1.next is node 3 and node2.next becomes node 1, and we return node 2 because this is our new head. Now if we implement that example, we can swap already 3 nodes. So let's write it down in our function. I'll just move the function lower so we have space. So I'll just copy paste this part into my function, right? So I already have something that solves this for the simplest case, right? Now we need to go to step number 6, which we saw also last time, is the step that solves the problem. And that says how to combine the answer for each simple case to get the answer for the whole problem. In step number 5, we saw that we solved this problem for the first 3 nodes, but how about further? When this is where we start thinking about the fact that we have a recursive function that returns a linked list. So we're dealing with linked lists. How does a linked list compose itself? It's by using next to go to the next node. So we see here that in order to solve for the other cases, we need to move the pointer to node 3 and continue. So meaning that it's not enough here to just say node 1 next is node 3. We need to continue to move from there. So what does that mean? It means that node 1 next, instead of pointing to node 3, how about it points to a call to our recursive function, who instead of passing in the head, the old head, we pass in node 3. And in this case, the new head becomes node 3 and we move from there. So you see already, because we know what data structure we work with and we know how to compose that data structure, we understood already how to create the recursive call. So now if we go ahead and modify our method here, instead of saying node 3, we said recursive function of node 3. And this is it, we solved the problem with only 6 steps. Of course, the 7th step is, if necessary, decide what to return, but in our case, we know already that we have a linked list and we need to return the head of the list. So we know that the head of the list now became node 2 and we return node 2. So that is already solved for us. And once again, just applying 7 steps, we created a function that solves our problem, and it doesn't even look like a medium complexity problem because we applied each step. So as a homework for you, try to draw the call stack of this function. So try to use what we learned in the previous video with what we learned in this video and create the call stack to test the solution of this function. That is the easy part. Every course about recursion talks about it, so there's no need for us to go in depth there. And we went already in depth in the previous video, so we don't need to discuss about it again. I think the point that I want to drive home is that applying the 7 steps makes any problem of any difficulty look easy. Now let's code our solution in Java and in Python so that we can see how this looks in code and how easy just copy pasting what we wrote here in the code will solve the problem. So I'll see you there. We will start with the Java implementation of our solution, and as we saw in the drawing and in the theory, the first thing we need to look at is the base case. If head is null or head.next is null, meaning if we have no nodes or one single node, just return the head. Now that we got the base case out of the way, let's solve the problem for only 2 nodes. So if we just had only 2 nodes, we need references to first node, and I'm gonna call it node 1, which is the head. It's list node. Node 2 is head.next because we need the second node as well. And in order to swap, we also need a reference to the third node. List node 3 equals node2.next. Now, if we only had 3 nodes and we had to swap the first and the second, we would do what? We would say node1 dot next becomes node 3 and node2 dot next becomes node 1, and we return node 2 because now this is the head of our list. Yeah, now if we will run this, of course it will not work, but it will have swapped the first 2 nodes. Sorry, here I forgot to say node 2 dot next. Yeah, so if you can see, the output is 2 1, which means that the first 2 nodes have been swapped, but the second 2 haven't been, because we only apply this case for the simplest case like we saw in the drawing. Now, in order to solve the whole problem and implement recursion, we have to find out the relationship between the solution to the smallest problem and combine all the solutions to the small problems into one solution using recursion. So since we have a linked list and we know that we need to create a connection between nodes, what do we need to do? Well, once we swap the first 2 nodes, we need to move to the third and so on. So then instead of saying here node 1 next is node 3, node 1 next, as we saw in the drawing, is swap pairs of node 3. And at this point, we created our recursive call and we combine all the solutions into one. So if we run again our code, we missed an S, so probably we'll have an error. Let's run it again. Now we have an accepted result because our solution works. We submit it and it works. It's faster than 100% of solutions. So that's great. Now that we saw how to solve this in Java, let's move on with the Python implementation of the solution. Now let's see how the Python implementation will look like. So I'll define a helper method here called swap pairs. We'll take in the head node, and of course our base case is when head is none or head.next is none, meaning that if I have no nodes or one node in the list, then just return head. Now we're gonna solve the problem for the simplest case, so we're gonna say first node is head, we need a reference to the first node, we need a reference to the second node as well, that will be head.next, and third node is of course the second node dot next. We also need this node. If we only had 3 nodes, which in this case is the simplest case for which we need to solve the problem, this would look something like first node next would be third and second node dot next would be first, and we would return second because now second is the head of the list. And here we will replace return none with return swap pairs of head. Now we run the code, and if we run the code, we see that only the first 2 nodes are swapped. And to solve the whole problem, we need to implement recursion. And in order to do that, we need to understand how to link this recursive call with what we already have. So we know that we have a linked list, thus we need to create a connection between the nodes and its reference to next. So in this case, what do we need to do? So we swap 1 and 2, now we need to move on to 3 and swap 3 and 4, which means that since we know how to swap these nodes, instead of saying first node.next is 3, we say first node.next, it will be swap pairs, we make the recursive call of third. So now our function will do the same for 3 being the head of the list and so on and so forth as you saw in the drawing. Now if we run again the code, we see that it works well, and if we submit it, we also see that it works well. I really hope that you enjoyed this segment of our algorithms and data structure course. If you did, or if you have any suggestions, please take a moment to leave a comment below. Next week we will move on to linked lists. Don't forget to like the video as it helps with the YouTube algorithm so that more people can benefit from this course. Also, please don't forget to subscribe and press the bell button to receive notifications when the next chapter of the course will be released. Thank you for watching, and I'll see you in the next one.